Hello and welcome to this sixth algorithm selection and development lecture in this course Master in Artificial Intelligence. So in this lecture we will talk to you about how does two indices, adjusted rand index ARI and adjusted mutual information AMI, measure the agreement between the true labels and the cluster assignments. So as you can recall, probably this is a part of determining type of output and their evaluation matrices. And we are talking about clustering as a type of output, and we are looking at the various evaluation matrices, including the ARI and AMI. So the adjusted RAND index ARI and adjusted mutual information AMI are two metrics used to measure the agreement between the true labels of the data points and the cluster assignments generated by the clustering algorithm. So it kind of figures out how well is your clustering assignment done, right? So you can use this to evaluate a clustering algorithm. Now, how does that happen? Let's take a look at that. So first, let's talk about the adjusted RAND index ARI. Now, ARI measures the similarity between the two clusterings, as you see here on your screen, taking into account the chance agreement. It computes the similarity between all pairs of data points based on their true labels and their assigned cluster labels. ARI considers all possible pairs of data point and calculates the fraction of pairs that are either in the same cluster or different cluster in both true and predicted clustering relative to the chance, right? And the ARI score ranges from -1 to 1, where ARI equal to 1 indicates perfect agreement between the true labels and the cluster assignments. ARI, when it is 0, indicates clustering assignments are similar to random chance, it's left to chance. And ARI less than 0 or negative indicates the clustering assignments are worse than random here, right? So here in the example of clustering on data set with k-means, there are two softwares that have been evaluated, k-means and mean shift on the right hand side, and adjusted RAND index for these two clustering is 0.94, indicating that these is very similar. There is a similarity between the two algorithms and they are computing the all data points correctly, right? The second thing let's take a look at is the AMI, Adjusted Mutual Information. Now, Adjusted Mutual Information measures the mutual information between the true labels and cluster assignments similar to ARI, adjusted for chance. It quantifies the amount of information that the clustering provides about the true labels while accounting for the inherent agreement due to random chance. So, including the effect of chance, what is the amount of information about the clustering provides about the true labeling? AMI considers the marginal and joint probabilities of data points belonging to specific clusters and specific true labels. Now, AMI scores ranges between 0 to 1, where 1 indicates perfect agreement between the true labels and the cluster assignments. AMI equal to 0 indicates that the cluster assignments are independent of the true labels or equivalent to random chance. And in case AMI is less than 0, indicates that the cluster assignments are worse than the random chance. They are biased, right? And here in the example, you see three clusters that where the AMI is calculated, and then you see the one with the 0.4852 chance is a very similar clustering that has been done. So clustering A and C are rated as similar, whereas cluster A and B and cluster A and D are non-similar. So the question now is, how can you interpret both ARI and AMI? Both ARI and MI provide quantitative measurable quantitative measure of agreement between the true labels and the cluster assignments. Higher values indicate better agreement, with 1 representing perfect agreement and 0 representing agreement equivalent to random chance. And negative values indicate disagreements, that is worse than the random chance. So that's how you can interpret both ARI and AMI. Now the question is how to use ARI and AMI for cluster evaluation. Both AR and MI are commonly used to evaluate the performance of the clustering algorithms and compare different clustering results. So they are used for evaluating the performance of the clustering algorithms, and they provide insights into the quality of clusters produced by the algorithms and help assess the effectiveness of the clustering process. So they are good measures for evaluating different clustering algorithms and cluster formation. So in summary, ARI and AMI are two metrics used to assess the agreement between the true labels and cluster assignments. They provide quantitative measure of clustering quality in a clustering algorithm. Now, what are the other types of output? In addition to classification, regression, and clustering, there are other types of output such as sequence prediction, anomaly detection, and ranking. Each type may have specific evaluation metrics tailored to its characteristic. Now, being able to guess the next element of a sequence is an important question in many applications. A sequence prediction model learns to identify the pattern in the sequential input data and predict the next value. Anomaly detection is a process of finding patterns in the data that do not conform to the model of the normal behavior. Detecting such deviation from expected behavior in the data over time is very crucial for ensuring normal operations of the system. Identifying the right set of anomaly triggers can help in taking right corrective actions. So when selecting evaluation metrics, you need to consider the specific characteristics of the problem, the nature of output that we saw, the goals of the analysis, and choose metrics and provide meaningful insights into performance of the model and align with the objectives of the task. So that's how you can determine the type of output and the evaluation metrics, over which we have spent quite a lot of lectures now. Additionally, it is important to consider domain-specific things and stakeholders' requirements when determining evaluation metrics. So what is next? So having looked at the type of output and the evaluation characteristics, we will now get into quickly recap the data understanding preparation that we covered in a lot of detail prior to this section, right? So we will do that quickly, and along with that we will cover other things also in the next lecture. So thank you so much for watching this sixth algorithm selection and development lecture. I hope you continue to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download the PDF file to take a look at anything that you need to.